Okay, so here we are. So we're trying to decide how I know that this problem is the same as this problem. Okay? Did I reduce correctly? So I can actually type the original problem into the calculator and what I think the problem becomes into the calculator just to make sure. So I'm going to type in 3 radical 18, and I'm going to get a decimal. And I want to see, is that the same thing as 9 radical 2? So I know I reduced it right. I can do the same thing with 2 radical 72. And let's see if it's the same thing as 12 radical 2. And it is. So I know that I reduced the problem correctly. Now can I add them? Yeah, I can actually add them now because what's underneath the radical is the same, so it stays the same. And what do I do with the numbers in the front? I add them. This was a problem that was very similar to one on your quiz last class. I'm going to give you your quizzes back next Tuesday, and you're going to be able to take them home and make corrections on them if you have an A or a B homework average. Not everyone in this class qualifies for that. Okay? Yes. And you're going to take yours on Monday after school, so I'll give it to you on Tuesday in class. Yes. Multiplying is different than adding. Okay, when you're adding, they have to be exactly the same. Yes.
So we only do that if they're doable. Like, so if it's like
if this was a 3, you couldn't add them. If this was a 3 under the radical,
so the radicals have to be the same, but
the numbers in front don't have to be anything. That's what you actually combine.
Okay, so, but you have to reduce those.
I do. I have to. Otherwise, you can't add them. Okay? So, Gabby, Monday after school for the quiz. Who else missed the quiz last class? Monday after school for the quiz. Okay? Because I need to give it back to you on Tuesday. So you have to be here on Monday to take it. Okay, yeah. Sure.
You know how we put 18 in 3 times 3?
Uh-huh. Uh-huh. I did this 2 times that 3, because I brought them, which is 6, times this 2, which is 12. No, you're taking out a pair. You're taking out 1. I took out 1 3 and I multiplied it by that 3.
Oh, I didn't see that.
Okay? Okay. You good now? Okay. All right, so let's go ahead and look at number 105. You should recognize problem 105 to be a special case. What is a special case in that problem? So what's that special word? The conjugates of each other. When I multiply conjugates, what should my final answer look like? Just a number, an integer. We shouldn't have any radicals anymore. So let's see if that happens. So in this case, I'm going to need to FOIL, multiply, distribute, however you want to think about it. 1 times 1 is 1. 1 times positive square roots of 2 is positive 2 square roots of 2. Then I have negative 2 square roots of 2. And then I have, what is this? What are the last terms multiplied? Minus 4 radical 4. And multiply both the numbers out in front and the numbers underneath, which is just 8. We'll get there in a minute. You can do that already. That's awesome. You can jump ahead. Not everybody's there yet, though. Okay, he got that to be 8, which is perfect. Okay, the last number is an 8 because the square root of 4 is 2. 2 times 4 is 8. So Oshome knew that that's negative 8. That's awesome. I don't think we're all at the point where we can just do that yet. So that's why I'm writing it out this way. What happens to the 2 numbers in the middle? Because I have 1 that's positive and 1 that's negative. I still have this lucky 1 out here. What's 1 minus 8? Okay, and didn't I expect that to look like that? I expected my answer to be like that, and that's what happened. Again, a problem like your quiz. Okay, this last one, doesn't that kind of look like the one we already did? They have the same index. The index is 4 this time. So when I reduce these radicals, I'm looking for groups of 4. So I have the square root of 162. So let's just kind of do that off to the side. Give me some numbers that go into 162. What, 2 and what? 2 and 81? I don't think so. Is it 2 and 81? Yeah. Oh, I'm sorry. Okay, 2 and 81. There's a bunch of different possibilities, okay? And it doesn't really matter which 2 you pick, because you're going to break them down to prime numbers at the bottom anyway, right? So 2 is already prime. I have 9 and 9. If I was a square root, I could circle my 9s and be done. But I'm not. I'm a 4th root, right? So I have to keep going. And I do have 4 3s, don't I? And what's left over under the radical?
2.
All right, so I have 3 4th root of 2 plus 3. Now I have a 3 there. So we'll have to probably multiply that by whatever we bring out in a minute. So let's go ahead and reduce the square root, or the 4th root, sorry, of 32. 6 times 6 is 36. What are factors of 32? 8 and 4, 16 and 2. There's not 16 and 2. Yeah, 16 and 2. Yeah, right. Okay. It's Friday, y'all. 8 and 4. Okay. So we have 4 and 2. 2 and 2, and then we have, bring them all down, so we don't want to lose anybody. I'm looking for a group of 2, I'm sorry, a group of 4. Exactly. I bring out a group of 4 2s, and I multiply it by the 3 that's already out in front. I'm multiplying it by that guy. So this group of 2s times that 3 gives me a what out front?
6.
Good. So I have a 6 out front, then I have a 4th root of what's left over, is this guy right here. Now can I add them? Is what's underneath the radical the same, or the indexes the same? So my answer is 9 4th roots of 2. Okay? Again, these are all kinds of like questions that you had on your quiz, right? We've got to pay attention to when do I add, when do I multiply, when is it okay to add, all that stuff. Here are the answers to your homework. And April, I need to see your homework since you just came in. Okay? Sure. Is there another one besides 26?
Can we just do 34?
16 and 34? All right. Isn't 8, 16 the same thing? Okay. Let's just do these 3, okay, and let's see how far we get. So let's start with 16. So in question 16, it says 2 to the 1/2 times 32 to the 1/2. Now, I want to be able to add the exponents, okay? I want that to happen, but in order to be able to do that, these bases have to be the same. It's kind of like what's underneath the radical has to be the same. They're not the same right now, but I can get them to be the same. That's exactly right. I know that I want the base, this 32, to be written as a power of 2. 2 to some power, because once the bases are the same, then I can add the exponents. And Travis is right. I want to change 32 to be the same as 2 to the 5th. Then it has the same power, the same base as its neighbor. The problem is that I have to take this 2 to the 5th and raise it to the what power? Because 32 is 2 to the 5th, but it's still raised to the 1/2 power out here. Now my question becomes, what do I do with these two things? I multiply them. How do I multiply 5 times 1/2? I could, but I mean, I don't have to. I mean, you could do it on your calculator if you're not sure. 5, oops, turn it on first. Here we go. 5 times, remember where you go your fraction, 1 divided by 2. I get 5/2, right? You can do that. Or you can just remember, well, it helps if you write without a highlighter here. 5 times 1/2, put that over 1 and go straight across. 5 over 2. Remember when you multiply a whole number times a fraction, you put it over 1 and go straight across? 5th grade right there. Yes, Travis? No, not yet. All we're doing is multiplying what I've highlighted in blue. We're not jumping ahead yet. So I have 2 to the 1/2. Hang on 1 second, Tim. 2 to the 5/2. The one in yellow is the original. You might have written it down wrong, maybe. Are the bases the same now? They're both 2's. Do you agree?
Yeah.
So once that happens, and I'm multiplying, this is a multiply, correct? I can add the exponents. It's kind of like this. Remember when I have x squared times x to the third? What do I do with those exponents? I add them, so it's x to the fifth. It's the same thing with this one, except for I'm adding fractions now. Not a big deal. What's 1/2 plus 5/2? Do they have a common denominator? 6/2. What is 6 divided by 2? 3. So it's 2 to the 6/2, which is 2 to the third. What is 2 to the third? 8, which is why the answer was 8. Now, if you were on a test or a quiz and it's multiple choice and it's an SOL and you don't have any variables, there's no x's, there's no y's, couldn't you just use your calculator? Couldn't I just type it in from the very beginning? So I can say, watch, 2 to the, I'm going to put it in a fraction, 2 to the 1/2 power, come out of it, times 32 to the 1/2 power, come out of it, and I get 8. It doesn't always work out to be a number like this, because often you have x's and y's. Okay? But if it doesn't, and the number does, just, I mean, it's a way to check your answer for sure, right? Okay, let's look at 26, because 26 has y's in it, which is something you wouldn't really be able to check on your calculator right away. So let's look at 26. Okay? I am eventually, before the SOL, going to show you how to use your calculator with these x's and the y's as well. So I have y to the 1.2 power.
Don't you just put them in?
Put what in? On the SOL, I'm going to show you how to, yes, to store. Use the store feature. We're not there yet. Why does this one look so different than every other problem we've done so far? Because it's not as a fraction.
Can I say 5%?
Yes, you can.
Well, I don't know if it's right. It's 1 over 2. I just divided.
It's not 1 divided by 2, though.
I know it's 2. I put 2 over 1.
It's not 2 over 1 either. Let me show you how to convert. Travis, we're really not worried about, I don't care that your phone's dead. We're in Algebra 2 right now. Your grade is dependent on your focus in this class right now. Stop doing the phone and pay attention to the algebra. Yes, sir. So this is a decimal. It should be a what? Fraction. How do I convert 1.2 to a fraction?
Oh!
Shh, hey, Christian's answering. And then I go to math, frac. The calculator converts any decimal to a fraction. I know. So, no, it's 1.2. Sometimes the decimal point does look like a multiplication sign, though. I agree. Yeah, it's 1.2. So once I have it as a fraction, I believe the directions say to convert it to radical form. So we have to do that. What is the index of this radical? 5, because it's the same as the denominator, and this would be y to the 6th. And I can reduce it because I'm trying to look for groups of 5. If I write y out 6 times, don't I have one group of 5 that I can bring out? So I do that, and then how many do I have left over? So that is my final answer. I think it did. It sure. Oh, it didn't. Yeah, I want that to be your answer. Okay, that. I want you to simplify it. Yeah, thanks. That's when you have an even index and an odd number that you bring out. Okay? Okay, the last one you guys wanted to see was 34. So let's look at that one. This is the one that most of you got pretty darn close to, but didn't finish it. So let's look at that one. So I have the cubed root of quantity 5xy to the 6th. Now, those parentheses are pretty important because it says everything is being raised to the 6th power. Well, not just the 6th power, but can't I rewrite this, and this is what a lot of you did, 5xy, all of it raised to the 6 divided by 3 power, which is 2. So we're going to do that, 5xy squared. And then because there are no pluses or minuses in here, can't I apply that exponent to everything on the inside? So it becomes 5 squared, x squared, y squared. So most of you stopped short. Okay. So these fractional exponents, you should be able to convert back and forth between them. Sometimes you need to put it in exponential form in order to be able to combine them. Today we're going to take, this is like our last section in radicals, okay, thank goodness. And then we're going to take our quarter test next week. Quarter test, remember how I said we were behind? Quarter 2 test next week, we're not going to do our own radical test. We're just going to do, the quarter test has 3 sections. A whole section on radicals. It's going to be a whole section on complex numbers, i's and things like that, and then a whole nother section. So I'm going to give you the review today that we're going to work on, and you're going to work on the radical section as your review. The test will be next week. It'll be for you next Thursday. Okay? Well, it's not fair. It's really fair. Yes. Do you have a question? Ask me later. Okay. So if you would, go ahead and take your notes out. We are going to look at solving radical equations. If you don't have a graphing calculator, you absolutely need one today, because we're going to solve it both algebraically and on the calculator. Travis, get yourself a calculator, please. Because you need to be able to do it both ways. Let's look at some equations and let's figure out some equivalent equations. Equivalent means that they're the same. They're just kind of rearranged. Some different things have happened. So this is a radical equation because it has a square root in it. Sometimes the radicals will have an index of 2. Sometimes they'll have an index of 3, 4, or 5. But we know this to be a square root. Which one of those 3 happens to be an equivalent equation? Which one? The first one, the second one, or the third one? Try again.
First one.
Try again.
None of them.
It's actually the third one. Because if I subtract 3 from both sides here, don't I end up with what I started with? So this would be an equivalent equation. When we talk about radical equations, I really can't change what's underneath the square root. When I multiply by 2 or when I add 3 or whatever I do to both sides, I'm not going to change what's under the radical. Okay? So let's see if we can do this here. Let's draw a line. Where are the solutions to this? Where's the solution in column B for the first answer here? What's the answer? What's x? Positive 2. No, you don't have to write this part down. Second one. If I add 4. If I add 4, negative 2. Negative 6 plus 4, right? What about here?
It's going to be negative this one.
Positive 10, because when I divide by 2, well, everybody gets a chance. Well, you're definitely mistreated. How about this last
I
one?
think it's only one left.
I think you might be right. So, but do you see how you can multiply by 5 and you would get negative 10? Okay, so we know how to solve these basic equations. So let's take this a little bit further. Okay, you don't have to write this down because I'm actually going to give you some guided notes here in a few minutes. So you're lucky today. I just want you to watch for right now. This is an equation. An equation, okay? And I'm going to show you first how to graph it, and then we're going to solve it, okay, algebraically. We're going to do it both ways. Now, the first step, anytime you want to solve a radical equation, which I have here, you have a square root, sometimes you have a third root, whatever, the first thing you want to do always is isolate the square root. What does isolate mean?
Get it by itself.
Good. I want to get it by itself. So if I have anything on the same side of the equal sign as the square root, I need to get rid of it. So look at that equation. What's on the same side? And I need to get rid of it. So how would I do that? I would add 5 to both sides. So do you agree that at this point I am here when I add 5 to both sides?
See.
Do you agree?
See.
Okay. So here I am. I'm going to show you how to go from here to solve it algebraically, and then we're going to check it using the graph. Sure.
Why wouldn't you just subtract that 5 with the 1?
Because when it's under the radical, you can't touch it.
Oh,
Okay? You can only get the radical. Everything by the radical has to be alone. Okay? You can't touch it if it's under it. Once I've isolated the square root, now I have the square root by itself. How do I undo a square root? Well, I'm actually going to square both sides. In other words, I'm going to take these and I'm going to square it. Take this and I'm going to square it. You don't have to yet. I'm going to do another one. I'm going to show you. I have guided notes for you in just a minute. I just want you to watch right now. Okay? This square and this square root undo each other, so I'm left with what's just under the radical. And then I have 25. Now I'm going to subtract 1, and I get here, divide by 4. This is my answer. Okay? Now, here's something that's important. Anytime that you square both sides of an equation, there is the possibility that we have introduced something called an extraneous solution. We talked about that back when we did absolute value equations, if you remember, back at the very, very beginning of the year. Squaring both sides also introduces that possibility. So we always need to check our answer. One way to check our answer, really, is to plug my answer back into the problem. So 4 times 6 plus 1 minus 5, does that equal 0? What's 4 times 6? 24 plus 1 minus 5. 25. What's the square root of 25? Is 5 minus 5 0?
Yeah.
So what do we know? That is the answer. Okay? So here's what I want you to do. I want you to plug this into the calculator. Okay, let me show you. You can plug it in one of two places. Please make sure that your plot 1 is not turned on.
so watch the square root.
I didn't square it. I squared it to get rid of the radical.
So anytime you square root a radical, it's a number under it.
Yeah, that's right. They undo each other. They're opposite. They are what I call inverses of each other, and they undo each other. So, a lot. Yes, darling. I'm listening. Uh-huh. Because all the squaring of both sides does is get rid of the radical. It just gives you what's underneath the radical. The square and the square root undo each other. Okay? That's all that does. That's the whole idea. Once you get the radical by itself, then you can square it and it's gone. Okay? And then you're just left with what's underneath. You don't actually square what's underneath the radical. Okay? All right, so notice on my calculator that you can't see on the smartboard, I have plot 1 highlighted. If you do, you need to go up there and turn it off. You should not have the plot 1 turned on. Remember, other classes use this calculator, and we use those plots, so you don't want that on there. I don't have it, though, on the one my smartboard. I'm going to plug in my original problem here. You can either plug it in here.
But how do you know the plot's on or off?
It'll be darkened if it's on. So I can plug in the original problem here, or I can plug in here. It doesn't really matter. But I'm going to go ahead and plug in the original. Okay? So I'm going to say the square root of 4x plus 1. That's all that's underneath my radical, so I'm going to arrow out of it, minus 5. Where am I looking for the solution? What does it equal in the equation? So if it equals 0, what am I looking for on the graph?
A straight line.
No. On the graph. I'm looking for something. The x-intercepts. When x equals 0. So let's go ahead and make sure we zoom standard so we get a really pretty picture. Oh, remember our dance? Square root function?
Uh-oh.
Right?
What was that? What was that?
Remember that?
I was doing it.
Okay. So not this, but it's just a function, right? Square root function. And is that the picture we assumed it to be? And it went, what, down 5? Remember transformations? That minus 5 does mean it's been shifted down 5? So it does, remember all this? It's all kind of coming back now. So what am I looking for? I'm not going to let me write on this, but I'll try. We're actually looking for that, aren't we? So how do I find that solution? Second calc, 0, good. And I'm going to go to the left, which means in this case underneath it, hit enter. Go to the right, which means above it in this case, to the right, hit enter. Enter on guess, and I should get 6. I got the answer.
Would you just do that?
I'll do it one more time.
You showed us 3 different ways to get the answer.
2 different ways. Did it help you on that?
You did the hand version, the calculator, and then you showed us the graph.
Now, would you, like, how do you...
Left means here, x-intercept. I'm going to go to the left. The graph is underneath here to the left. Press enter. I'm going to go on the other side of where the x-intercept is, which in this case is to the right. Hit enter.
Wait, do I have to
Guess
hit
enter.
intersect?
Not intersect.
What do you mean?
0. You're looking for the 0, the root.
Then go over here.
And go on either side. So hit enter.
Enter.
And go on the other side and hit enter. Okay?
You just already...
I know. So, in this particular, you have these in front of you. You're going to fill out your steps as we go along. Okay? This one looks different from the very get-go because it doesn't equal 0. So when we're looking for something that doesn't equal 0, the way we approach it on the graph will be different. So that's important. But let's solve it algebraically first. Algebraically, do I have, the first question, do I have the radical isolated?
No.
Is there anything on the same side of the equal sign with the radical? So is it isolated?
No.
Yes.
Oh, it is.
When it's by itself, it's done. There's stuff under the radical, but is the radical have anything added or multiplied with
So
it?
when you square it?
Now, right now, I square both sides. It showed me that. I squared both sides. So I'm going to do the same thing over here. I'm just going to follow along with the steps. Patrick.
If you have an index that's not 2, is it considered isolated? Or?
It is. We'll get to that. That's a really, really good question. If the index isn't 2, like let's say it was 3, you would actually cube both sides. If the index was 4, you would raise both sides to the 4th power. Great question. All right. So I have the steps on the left. I'm going to do the work on the right with a different problem. So over here, I'm going to take the square root of 5x plus 1 equals 4. The index is 2, like Patrick said, so I'm going to square both sides. At this point, you look over here on the left-hand side, it says simplify and solve. What does the square root of 5x plus 1 all squared come down to?
5x plus 1 equals 8.
No. 4 squared is 16. Okay? I get it. It is Friday. My next step is going to be to subtract 1. Now it's familiar. Now this is like Algebra 1. I'm good. Subtract 1 from both sides. So 5x equals 15.
5 and 3.
Yeah, x is 3. Good.
Do you see how things get so easy?
Yes, baby. How do we check it? There's 2 ways we're going to check it. The first way, we're going to check it just by plugging it back into the equation, the answer we got. The second way is checking it on the graph. I'm going to show you how to do that in a minute. Let's check it this way first. So step 3, I'll do it in a different color so it doesn't mess up here. But step 3, we're going to check it.
Can we make a solve?
The square root of 3, I'm sorry, 3, we're in the wrong problem. 5, because we're doing this problem, right? 5 times 3 plus 1, does that equal 4? Because it's the square root of 16. Is that 4? Yes. So it works. Now I want to check it on the calculator. Now here is where I need everyone to pay attention. Okay? I'm plugging in the original problem, but here's the issue. The problem that we did the previous problem, it did what? It equaled 0. Now it doesn't. So you have two choices. I can either subtract 4 and make it equal 0 and do it like I'm familiar, or I can plug, and this is what I think might be a better way. If it doesn't equal 0, I can plug the left-hand side as y1, the right-hand side as y2, and calculate the intersection.
I have a question.
Okay? A lot easier.
So if you just subtract negative 4, is that?
You could, it could be, you're right. I could plug this in and look for the 0. Absolutely. And I will get the same answer. Actually, will I have some of you do that for me? Can you do that, Tim? Do that. Okay? And then we have your way. So you can do it either way. I'd like for someone to do it with the green way, and April's already done it the other way. That's fine. Perfect. Can you plug yours into the calculator with the green way, Daniel? All right, I'm going to do it with the y1, y2. So let me show you what I mean by that. And this is actually, folks, if you do it this way, trust me when I say on an SOL or anything else, if you have any kind of equation at all and you don't know how to solve it, if you plug the left-hand side as y1 and the right-hand side as y2, I don't care what it looks like. You can have all kinds of crazy numbers, square roots, absolute values, whatever. All you have to do is find the intersection of the two, and there's your answer, no matter what. So it's a good strategy on anything. So if I go to y equals, I'm going to clear that out. Just on the left, y1, I'm going to plug in the square root of 5x plus 1. That's it. And then y2, I'm going to plug in a 4. Because what's on the left-hand side goes in y1, what's on the right-hand side goes as y2. And then if I graph it, you're looking for the intersection of the two graphs. Now you're not looking for the 0 anymore. So if I calculate the intersection, which is option 5, calculate second calc, option 5, it's going to ask you first curve, second curve. So you see your int function, your square root function, and then you see your y equals 4. So it's going to watch it jump. Starts at the first curve, then it jumps up to the other curve. It's a line. And the answer was, well, we only care about the x, don't we? Yeah. The answer is 3, which is what we got algebraically. Oh, but if you look at what Daniel did, and that's over on the side calculator, he did it using the green method, which is the 0, and he found it too. Either way works, okay? That's a problem. If there's other variables, we only want to have one variable. Okay? Let's try the second one. Okay? Let's try this. Where did you lose? Did you do it the green way or did you do it the... Yeah, the green way is what Daniel did up on the calculator, and what I did was the other way. When you get it equal to 0, that's a root. This is the y1, y2 way, right here. The white way. All right. Everybody else, go ahead and let's go to the second one. Tim, I'll be right there to help you. Go ahead and look at this one. And this is what Patrick was looking at. The index is not 2 anymore. The index is 3. So this case is different because the index is a 3. It's no longer a 2. I'll show you in a minute. Is the radical isolated? Okay. Both of these happen to be isolated. They're not always isolated. But this one was. So in this case, I'm going to bring each power, I'm going to cube both sides, which means I'm going to raise each side to a power of 3. In other words, the index and the power you raise it to should be the same. Okay? Because it's a cube root, the index is 3.
Oh, sorry.
Everything's going to be raised to the third power.
The goal is to get rid of the radical.
Exactly, that's my goal, to get rid of the radical. Perfect. So 2x minus 1, so I'm going to go ahead and cube both sides. 2x minus 1 equals, what is 5 cubed? 125. Now it looks familiar, doesn't it? Add 1. Divide by 2. Let's check it. There are places where it won't work, so we'll get to one.
So you do it the green way or the white way?
I'm going to probably do it the y1, y2 way, but that's up to you. Only because it works for anything, and I think it's a good practice for us. So I have the cube root of 2 times 63 minus 1. Does that equal 5? It's just hidden behind it.
No, I'm talking about the other one.
Can you guys work?
Hey, well, it's on the other side, baby. But we have one more to go. Because you can't. All right. So I'm going to go ahead and check my answer. Remember y1, y2. We want to use the graph. So go to y equals. And we will plug in a 5 here. What's underneath the radical is 2. Oh, it's a cube root too, so clear this totally out. Yeah. Go to cube root. Because the cube root of 125 is 5. And then I'm just going to graph it. And I'm going to look. What's going to be the problem with this graph? Notice what the shape of the graph looks like. Cube root function. We're dancing, okay, because we're so happy. What's the problem with the graph and the answer? It does intersect, but it doesn't intersect. You don't see it. Why not?
Because you got the
63 is a big number, isn't it? So you're going to have to extend your graph all the way down to 63 in order to be able to see it. So if I go to my window, what am I adjusting? If I'm trying to go my x to go all the way to 63?
you adjusted the x-axis.
X max. So I'm going to make my x max go to 70 just so I can see to make sure 63 shows up. Now let's graph. They're supposed to intersect. Let's see if they do. No, I did it this way. Do you see where they intersect? It's hard to tell, but I think they do.
Can't you zoom box?
I could, but I'm just going to go ahead and calculate it and see if it'll do it. Calculate the intersection. And I'm just going to literally hit enter 3 times. I do get 63. So it worked. Window.
Check it, like, is that necessary?
Window max. The reason I'm showing you this is because on any equation you can solve it this way. Any of them. Patrick. Second calc. And then go down to intersection. Option 5. You see it? And then you just hit the graph 3 times. Hit enter 3 times. It's going to ask you first graph, first curve, second curve, and then guess. And you should get it. Well, first of all, I don't see that you plugged it in correctly because you did the cube root. You got to do the cube root, not the square root.
All right, so you got a first curve and then the top.
All right, so here's an example of one that will have extraneous solutions. And it's different, and Tim noticed it right away because I have an x on both sides, right? So when I square both sides here, now we really introduce the idea of an extra answer, okay? And that's what's going to happen. So here's a question. No. Only if it was x squared. And it's got a plus sign, so you can't do that. I know what you're thinking, but you can't do that. Is a radical by itself? Okay. Now, on all 3 examples, it was. The first example we did, it wasn't, right? We had to add 5 or something like that to both sides first. That will happen sometimes. So here, if you notice, we have a radical. Is the index 2? So I am going to square both sides. So when I square both sides, I get 2x plus 8 equals x squared. All of a sudden, I have a what kind of equation? Begin to the Q.
Binomial.
Begin to the Q. Quadratic equations. And when I have quadratic equations, I know how to solve them. I have a Vinny, his brother. Okay. Huh? I see him. Sorry. Okay, so I've got quadratic. How do I solve a quadratic, Mr. Russell?
So set it equal to 0.
There you go. Which way do I want to go? Do I want to move everything to the left or everything to the right?
To the left.
Why? No, not to the left. I want to go to the right. Why? I want the x squared to be what? Positive. Yes, baby. Huh? Yes. I want to get the x squared to be positive, okay? So I want to move everything to where the x squared will be positive. So I'm going to subtract 2x, and I'm going to subtract 8. I just want it to get to be 0. Quadratic equations, I want it to equal 0. And I just moved everything to the right-hand side, so my x squared will remain positive. Yes?
Could you do it with the negative x squared?
It's harder to factor. Okay, so I prefer you not to do that. It is possible, but the negatives will often, they cause hazards. I'd rather not do it that way. All right, so now April sees that we need to factor this, and she remembers I have to kind of, the way that we did it, we had to figure out two numbers that multiplied to be negative 8 and added to be negative 2. So what are two numbers? Negative 4 and positive 2. Good job, April. I lost you where? Hang on. Pause. Are we okay with this? I'm just factoring. Two numbers have to multiply to be negative 8 and add to be negative 2. Remember this now? But you have to check your answers because one of them doesn't work. Yep, so the answers, once it's factored, I set each of those factors equal to 0.
Why does it look like a 2? Is that plus?
It's plus 2. So x is equal to 4 and x is equal to negative 2. I'm here to tell you that one of those answers doesn't work. One of them is extraneous. I can check it by plugging it in, plug in both of these into my answer, or I can graph it. Now, when I graph it, I'm going to graph it the left-hand way, the y1 way and the y2 way. Let's see if I can figure out which answer does not show up. Either 4 or negative 2 will not show up. So let's see. So I have the square root of 2x plus 8, and I have an x. Now I'm going to go back to Zoom Standard, because if you remember on the last problem, I made my x real big, didn't I? Made my window real long. So I'm just going to Zoom Standard again, just so I can get a pretty picture. And I'm looking for where the two graphs are going to intersect. I got a pretty picture. It is a pretty picture. Okay? So here I don't need your pretty picture. So here we go. You're gross. So here we are. So here we go. We're going to go ahead and calculate the intersection. So calculate the intersection. Remember what I do it the highlighted way, y1, y2, I'm looking for intersection, not 0 anymore. And I literally just hit the enter button 3 times. Did I get 4 as an answer? So that means 4 is an answer, which means this is the extraneous one. It only crosses in one place. Good?
That's it?
That's it. Question, Eric. Calculator question? Okay. If you'll turn this paper over. Oh, hang on. We do have to do one more problem. I apologize. I need to do this one.
You need the division one.
Division's totally different. Let's look at this one. This one's a hard one. Can we do this one, please?
You have a division one, right?
So I'd like to look at this one first. So you'll need to copy this one into your own notes because I don't have it on this paper. Okay? So this is the last one, the last example we're going to look at today. Let's think about what we've done so far. We've looked at equations that have all kinds of radicals in them, square roots, cube roots. We've gotten the radical by itself, which is what we've wanted to do. We've had to square both sides, cube both sides, whatever. But now I have something different. I have two radicals. Is it possible to isolate the radical here?
Yes.
Well, not both of them at one time, but I can pick one to get by itself. If I was going to choose which one I wanted to get alone, which one would it be? The bigger one. I agree. So we want to get this guy by itself, okay? So what would I do to isolate that radical? Good. Perfect. That's exactly what I'm going to do. I'm going to add radical x to both sides. Okay? Yes, sir. So all I've done is I have added the square root of x to both sides. Okay? That's all I did. I just isolated the bigger of the two radicals. Okay? I'm still going to square both sides here. But when I square the right-hand side, it's going to get a little trickier. So I'm still going to do the same process. I isolated the bigger radical. I'm going to square both sides. The left-hand side's easy. What does the left-hand side become? 5x plus 4. Done. That's easy. But the right-hand side becomes a little trickier. Little Beastie Boys just came into my head. I'm singing to myself. That's all right. I need someone to play it on the music for me in the background. So how do I square that to get rid of that radical? Remember, that's what I did in every other equation. Yeah. So now I've got to do this off to the side. So the square root of x plus 4 squared is just the square root of x plus 4 twice. This looks like the quiz to me. Don't you think? This looks like the stuff we did before. It's like worlds are colliding. Now I know why we had to do that, Miss Mackert. How do I solve it? How do I multiply these things? I got to FOIL it. Good. Square root of x times the square root of x. Square root of x squared, which is just x. I'll just write it down. Square root of x squared. We'll go ahead and simplify it in a minute. What's a square root of x times 4? 4 square roots of x plus another 4 square roots of x plus 16. Whew. Now this is new. You've never seen this before. Trust me. What is the square root of x squared? What is it? Nope. It's just x. Good. So I have x plus. Can I combine these guys? Are they like terms? So that becomes what? 8 radical x. Oh, that's supposed to be an x, sorry. 8 radical x. And then I have plus 16. I don't think I can go any further than that. Can't combine anything else, can I? No, because they're adding, not multiplying.
So that's it?
Not done.
Oh.
That's what they got too. We're lucky. Okay? So we're good so far.
So that was the other side.
Well, I still have a radical equation. I still have a square root in there. So what should I do?
Wait, that does not look like that.
Yeah, it does. It's exactly like that on the right-hand side.
Oh.
But hang on one second. I still have a radical, don't I?
Yeah.
So it's still a radical equation. So is it isolated? So what should I do? Not yet. Let's get rid of everything that's with it. Let's isolate that square root of x, okay? When I isolate that square root of x, I'm going to do what? How do I get the x by itself? Take down the 16. And not yet, take down the x. So when I subtract the 16 and subtract the x, this is a very long, very multi-step. I agree. Lots of steps. So I'm trying to break it down. Okay? 5x minus x is 4x. Negative 16 plus 4 is negative 12. Is the radical isolated yet? Not yet. Now I have to get rid of the what? The 8, the number in the front. How do I get rid of that 8? Divide everything by 8. Good. So I'm going to divide everything by 8. Whoa, hang on a minute. Oh, they divided everything by 4. Is that okay with you?
No.
Well, otherwise, if I divided by 8, wouldn't I have some fractions? So, because everything is divisible by 4. So you just divide it by a number so that way you didn't have fractions to deal with.
So they took the one from the left and divided it by 8.
Yeah. That way you don't have fractions, that's all. If you want to divide by 8, it would still work. You would just be dealing with fractions, that's all. You have to show me algebra. We are in a class called algebra. It's the name of the game. I know, this is a big problem. And I would only give you one like this on the test. It's a big problem.
Laws of physics.
But I will show you how to plug it in to find the answer on the calculator. Okay. Now, all they did was square both sides. Notice I had to square both sides how many times? Twice. When you have two radicals in an equation, you will square it twice. That's what happens. I know it's a big problem.
So it's x minus 3 twice.
X minus 3 twice again. Now I got to FOIL again.
Oh my god.
But before we get to the left, are we okay with how we got to the right? 2 squared is 4. The square root of x squared is just x. Holy moly. So x minus 3 squared.
No, that's going to be x squared minus 3x minus 3x and then 9.
Which becomes?
It's going to be
Negative 6.
Uh-huh. Good.
Take the 6 and subtract the 9.
Not yet. No one has an x, one doesn't. I want to actually get, if it's quadratic, I want it to equal 0. So how do I get it to equal 0?
You asked if
No, subtract.
4.
Very good. Subtract the 4x. This one over here. I want to get rid of it. I want it to be 0. Right? So now I have this. I'm close. I feel it. Well, I've got to factor it. Okay? I got to factor this now. Again, notice if I have 2 radicals, I had to square it both times. I'm going to have to factor 2 times. Are you kidding me? This is beautiful. Look at this math. You ever sit back and look at this and be like, I actually understand this. I'm pretty smart.
You did it all.
No, but you're following along, right? And you are going to do it all on your own. You understand the process. I think sometimes you got to take a break for yourself and really look back and say, man, I'm pretty smart. Because you are.
That problem is pretty long.
It is. And the fact that you can understand what's going on is actually half the battle, quite frankly. All right, so here we are. I'm going to factor. I've already done it, so I'll just show you. So 2 numbers that multiply to be 9 and add to be negative 10 are negative, no, that's wrong, are negative 9 and negative 1, right? A negative times, huh?
Where'd you plug in the red over onto the right? What you factoring? Where'd you plug it in?
Put it right here. No, I just factor. I factored.
Oh, I see.
So when I factor negative 9 times, if I do 2 numbers that multiply to be 9 and add to be negative 10, They're negative 9 and negative 1. So x minus 9, x minus 1, I set each of those factors equal to 0. My two possible answers are here. Now, do you think they both work? I don't know. Maybe. How can I check? Calculator, or I could plug them in. Now, if you are going to check on a calculator, I want you to show me the graph. Just sketch it. So you can prove to me that you actually plugged it in. Okay?
I don't think I would ever. I think I would just put a problem like this.
No, you wouldn't. Because you want to be able to get it. So let's look at the original problem.
That problem took
For the
25
quarter
I
check,
know, it
can you
did.
just give us 2 of these problems?
You get one of these. Just one. That's all you would get.
This problem only took 25.
I know, it's a big one. So let's go ahead and plug it into the calculator. Again, what's left on the left goes on one side. Notice there's two radicals. Square root of at 5x plus 4. Get out of the square root minus another square root x. All right, so on the left-hand side, you have y1. On the right-hand side, you have y2. Shh, guys, we got to get through this before I give you your homework. Okay, I'll text you the homework, and it'll also be on School Fusion. Then you have to check School
Oh,
Fusion.
miss, I got a new number.
All right, so I'm going to go ahead and click Graph. What am I looking for? The intersection here. I think I see it over here. What were my two answers? 9 and 1? Is that right? So I think it was positive 9 and 1, wasn't it? The final answers. So if I calculate the intersection, I'm going to hit enter 3 times. 9 is the only answer. So which one was extraneous? The 1. So I know that that's extraneous. 9's the only answer. Where you lost, babe? Right. I'm going to go ahead and if you need to print these notes, they'll be available on School Fusion, but we only have about 5 minutes, and I do need to assign you work. If you have individual questions, I'll be glad to answer them. The back problems are not going to be your homework. I know there's 5 of them there, but you see how you have some fractions there, okay? And so I think we might need to come back and look at these next class.
All right, yeah.
So what I want to do is assign some problems from the textbook, okay? So let me go ahead and give you some equation problems to do. Please let me finish. If you don't have a graphing calculator to check your answers at home, you have to check them by plugging them in. So if you look at the previous problems that we looked at, hang on, where you had it like this, oops, holy cow, like this problem here, where you had to actually plug in your answers, that's what you'll need to do. If you check it on a graphing calculator, you need to show me the graph, okay? One of the two. So here's your homework. It is on page 395. And we're going to look at problems 10 through 16 even. I'm going to give you a couple more to do. I'm going to give you actually one of the harder ones, okay? I'm going to have you do 35. That's not so hard because the radicals go away right away. And I'm going to have you do 42. That's the only problem. The last problem is one of the longer ones. You can imagine that'll probably be the extra credit one, okay? I'm just telling you ahead of time. All right, all right.